Hello viewers, in today's class we are going to solve yet another important problem related to three-dimensional geometry, right? So here again we have a plane and line, right? So here we have to find the coordinates of the points where the line through A, that is 3 comma 4 comma 1, and B, that is 5 comma 1 comma 6, crosses the xy plane, right? So what we have to do here, we have to find the coordinates of the points, right, where a line passing through these 2 points crosses the xy plane, right? So let us take the axis here. We have the three mutually perpendicular axes. So this is the z-axis, this is the x-axis, and this is the y-axis, and this is the origin, right? Now here what we have to do, see here the line is passing through A and B and it is crossing the plane xy plane, right? So we see that the xy plane is given by this plane, right? So this is the xy plane, or we can say XOY plane, right? And we know that any point which lies on this XOY plane has its z coordinate 0, right? So if we have any point, say P, lying on this plane, that is XOY plane, then obviously the z coordinate that is x comma y comma 0, that is the z coordinate is 0, right? Okay, so this is the concept which will be utilized here to obtain the coordinates of the point where the line crosses this plane xy, right? So let us start. So here we have a line which is passing through these 2 points, and we know that the standard equation of a line which passes through 2 points, say x1 y1 z1 and x2 y2 z2, is given by x minus x1 over x2 minus x1, y minus y1 over y2 minus y1, and z minus z1 over z2 minus z1, right? So here these quantities, that is x2 minus x1, y2 minus y1, and z2 minus z1, are the direction ratios of the line L, right? So now taking x1 y1 z1 as 3 comma 4 comma 1 and x2 y2 z2 as 5 comma 1 comma 6, let us write the equation of the line. So we have x minus 3 over 5 minus 3. Here we have y minus 4 over 1 minus 4, and z minus 1 over 6 minus 1, right? So now we have the equation of the line as x minus 3 over 2, y minus 4 over minus 3, and z minus 1 over 5, right? So this is the equation of the line, right? Okay, now this line crosses this plane XOY, right? So let us take the line. This is a rough diagram, and let us take the line like this, and here we have the line L, and it crosses this plane XOY, right? So at this point the z coordinate is 0, right? So now to find out the coordinates of this point P, let us find out the general coordinates of any point lying on this line L. So what we will do, we'll equate all these three terms to lambda, where lambda is some scalar. So now we have x minus 3 over 2 is equal to lambda, y minus 4 over minus 3 is equal to lambda, and z minus 1 over 5 is equal to lambda, right? For some particular value of lambda, we'll have this point P, right? And we have to find the value of that lambda, right? So now we have x is equal to 2 lambda plus 3, y is equal to minus 3 lambda plus 4, and z is equal to 5 lambda plus 1, right? Okay, so now we have this point x comma y comma z, right? And we see that here the coordinates of this point P are now 2 lambda plus 3 minus 3 lambda plus 4 and 5 lambda plus 1. And we see that here the z coordinate is 0, so we have to make this term 0, right? So we have z equal to 0, so we have 5 lambda plus 1 is equal to 0, so 5 lambda is minus 1, so lambda is equal to minus 1 over 5, right? Now we substitute this value of lambda over here, so x is now 2 times minus 1 over 5 plus 3, and y is minus 3 times minus 1 over 5 plus 4, and z is obviously 0, right? Okay, so z is 0. Now here we have minus 2 over 5 plus 3, here we have 3 over 5 plus 4, and here z is 0, and here we have minus 2 plus 15, 5 3s are 15 over 5, so this is 13 over 5, and here we have 3 plus 5 4s are 20 over 5, and here we have 23 over 5, right? So we have now obtained the value of x and y, right? So therefore the coordinates of this point P, where this line L, it crosses this plane x or y, the coordinates are given by 13 over 5 comma 23 over 5, and z is 0, right? So this is the required coordinate of this point P, right? So here we have to mention one more important thing, that if we have to take say xz plane instead of xy plane, then what we have to do in that case, we have to make y is equal to 0, right? And if we have to take a yz plane, then we have to equate x equal to 0, right? So viewers, this is how we solve this problem.